Here's an example of using the cross product for points in geometric space. So we're given 4 points, and we want to verify that they're vertices of a parallelogram, and then we want to find the parallelogram's area. So the safest way to do this would be if we were to plot all 4 points in 3-dimensional space, and you could kind of visually inspect to see which ones are the points of a parallelogram. And if it comes to it, I'll do that. But probably the simpler way is to figure out what the configuration is that gets me a parallelogram. So it could be that it's A, B, C, D, and I simply have to compute the vectors there and determine if they're parallel. But it could also be something like this, ACBD. And if that's true, then computing AB won't get me one of the sides, it'll get me the diagonal. So we need to be careful when we plot this out. So one thing you might consider doing is actually plotting it in 3D first. But if you don't feel comfortable doing that, maybe you should practice. But you can always try to get it the old-fashioned way. If it doesn't work out, we can fall back to graphing. So let's make an assumption. Let's make an assumption that it actually falls into something that resembles that. So let's get these vectors. Let's get AB. Let's get BC. Let's get CD. And let's get AD. So AB, starting at A, initial point A, terminal point B, will be 1, 2, 3. And BC will be, looks like 5, 4, 0. And CD will be -1, -2, -3. And AD will be 5, 4, 0. Okay, so what that tells me is that BC and AD are parallel. And that also tells me that AB and CD are parallel, but they're in the opposite direction. So it might have been smarter to think of the vector DC and now we have 2 sets of parallel vectors. So since we did that, we don't have to graph it in 3D. We don't have to second guess ourselves. It looks like we have our vectors here. So then what we would do is we want to get the magnitude of AB cross AD. Right? AB cross AD, the magnitude of that cross product is the volume of that parallelogram. So to get AB cross AD, I have to fill this out. So I say 1, 2, 3, 1, 2. 5, 4, 0, 5, 4. And then I want to go across. So that's 0i plus 15j plus 5k minus 10k minus 12i plus 0j. So my cross product here is negative 12i plus 15j minus 5k. So then if I want to get the magnitude of that vector, if I want to get the magnitude of the vector that we've just created, negative 12 squared plus 15 squared plus negative 5 squared. 144 plus 225 plus 25, 394. And 394 splits into 2, 197. And that might have some sort of factorization, but I am failing to come up with it off the top of my head. So we're going to say that that is our answer. And so that's how we find the volume of that parallelogram.